Right, welcome to another video. Today we're looking at question 8b. I should write that somewhere. 8. Okay, from the May 2023 paper 1. So let's see. We are given this expression 5 to the minus 1 times 75 to the 2x divided by 15 to the 4x times 3 to the negative 3x. Okay, and we're told that that is equal to k times 3 to the x. Okay, I don't think that random semicolon is meant to be there. Anyway, so we're told that that bombastic looking expression is equal to k times 3 to the x, where k is a constant, aka some integers, well, not necessarily an integer, but probably going to be at least a rational number. Okay, and we're asked to determine the value of k. So this is a simplification question, right? We're going from a complex looking expression to something that's just going to look like 2 times 3 to the x, or 10 over 3 times 3 to the x, or something like that. Right, so we're dealing with an expression on the left hand side that has 4 different bases. We've got 5, 75, 15, and 3. So in a situation like that, you want to try and get as many common bases as possible, and the way to achieve that is to use our prime factors, right? So we know that, okay, 5 is a prime number, so we can't break that down any further. 75 is equal to 25 times 3, which is 5 squared times 3. So let's say 3 times 5 squared. 15 is just equal to 3 times 5. Okay, and 3 is a prime number, so our work is already done there. So I'm just going to put that in a corner. Oh, what's happening? What's happening? Right, let's try to put it in a corner as promised. Okay, so just going to squeeze that over there. All right, so let's see if we can use our prime factorizations to rewrite this expression. And already our prime factorizations are looking quite nice, because 75 we've written in terms of 3 and 5. Oh, I left a power behind. And 15 as well, we've managed to write in terms of 3 and 5. So we're going to go from having 4 different bases to actually just having 2. Right, so, whoa, this expression over here, maybe let's start by writing bits of the expression, rewriting them. So 75 to the power of 2x is going to be the same as 3 times 5 squared to the power of 2x, right? And we know from our laws of exponents that a, let's say to the power of m, times b to the power of n raised to the power of x is going to be equal to a to the power of m times x times b to the power of n times x, right? So yeah, so we can use that rule. I don't know what happens when I get to the bottom of the page. There's just some funky stuff that happens. Anyway, so we're going to apply this rule to then simplify this expression over here. So we've got 3 to the power of 2x. Yo, it is getting hot in here. My goodness. Let's try this again. 3 to the power of 2x times 5 to the power of 2 times 2x. So that's going to be 5 to the power of 4x. Okay, cool. And we're going to use the same rule to simplify 15 to the power of 4x, or express it differently rather. So 15 we said is the same as 3 times 5. And we're going to raise that to the power of 4x. So that's going to be 3 to the power of 4x times 5 to the power of 4x. Whoa. Right, so let's quickly what shall we do? We can move this over here. Yeah. And make this whole thing smaller. Oh, no calculator, sorry, not your chance yet. Oh, I've touched something else. Okay, let's try that again. Oh, the joys of writing skew. Okay, I don't think I'm going to win. I don't think so. Maybe let's make this one a bit smaller. Okay, so there's our one. Okay, I keep hoping that I can still win. Am I foolish to believe? Yes, I am. I am very foolish. Okay, let me stop forcing matters. Right, we've kind of seen the point. In fact, maybe it would probably be better to... We saw how we got to that. We saw how we got to that. Oh, okay, no, not that one. So let's see if we can improve our lives here. Yes, we can. We are winning. We are winning. Oh my goodness, we are winning. I'd like to thank my mom, my dad. Okay, we left the period behind. Not great, not great. Okay, you can come along, my friend. Right. Whew. That was a very long detour. Anyway, so I think we can get rid of these guys over here because we're done using them. So let's see if we can now look at our expression. Right, so we've got 5 to the power of minus 1 times 75 to the 2x, which we've now rewritten like this. Okay, so we're going to times it with 3 to the 2x times 5 to the 4x. Okay, and then in the denominator we've got 15 to the 4x, which is just 3 to the 4x times 5 to the 4x, okay, times 3 to the minus 3x. Okay, perfecto. And now we can use our laws of exponents to work with the powers that have the same bases, right? So if we multiply powers that have the same base, we can add the exponents, and to divide, we can subtract the exponents. So we're going to work with the powers that have base 5, and we're going to work with the powers that have base 3, right? So this is going to simplify to 5 to the minus 1 plus 4x minus 4x, right, which is already looking lovely. And just to highlight where we got that, minus 1 plus 4x, and then because we're dividing, we have to minus 4x, right? So that's where those powers are coming from, right? And then let's simplify the bits involving base 3. So then we've got times 3. Ooh. Okay, I think let me move the page up a bit because things tend to be a bit more predictable there. Right, so we've got 3 to the power of 2x, right? And then we just have divisions. So we're going to divide by, right? And in the division, so and the bottom, we're multiplying 2 powers of 3. So we're going to add those exponents together, right? So we're going to have 4x. Okay, I think I'm writing funny because I'm getting nervous about space. So let me make this smaller. Okay, and then let's move this guy up. Okay, we will also make him proportional in due course. Right, so we're going to say 4x plus minus 3x, which is just the same as minusing 3x, right? And if we simplify, so let's make this smaller just so things don't look so scary. Okay, so that's pretty much what we're doing there. So if we simplify the first bit, we've got 5 to the minus 1 plus 4x minus 4x. So these two terms cancel out. 4x minus 4x is 0. So we're just left with 5 to the minus 1. And then in the second bit, we've got in the brackets 4x minus 3x. So that just ends up being x. Okay. And then we've got 2x minus that x. So 2x minus x is just 1x or x. So we have 3 to the power of 1x, or just x. Right, and if we look at what we were trying to achieve to begin with, okay, we wanted to simplify, simplify this expression, okay, whoa, right, simplify that expression so that it looks like some constant times 3 to the x. Let's see where we are currently. We currently have, oh, it took away my little x. My goodness. 5 to the minus 1, right, which is just the same as 1 over 5, right, times 3 to the power of x. So this tells us that k is equal to 1 over 5, right? And again, nice thing with algebra is that you can test this, right? So what we have just discovered is that if we choose any x, okay, and we substitute it in there, right, wherever we see an x, we put in that number that we've chosen, be it 0, be it negative 10, be it 1, then that expression should be the same, or should evaluate to the same number as 1 over 5 times 3 to the power of that same x that you chose. So maybe let's just quickly humor ourselves. Let us choose, let's say x is equal to 2, right? So we then have, not what I want to do, 5 to the power of negative 1 times, times 75 to the power of 2 times 2, okay, and at the bottom we have 15 to the power of 4 times 2, and we're going to times that with 3 to the power of negative 3 times 2, right? So wherever I see an x, I've just put in this number that I dreamt up, which was 2, right? And we see that that evaluates to 1,8 or 9 over 5. So let's hold on to that answer. So if I then put the same x into the right hand side, right, I have k is equal to 1 over 5, and if I times that with 3 to the power of 2, you see that we get the same thing, we get 1,8. If you chose an x and you put it into the left hand side and you put it into the right hand side and you got 2 different results, then you would get a suspicion that maybe something went wrong somewhere, and you would know to double check your steps. Right, let's see if the memo agrees with us. Yep, k is equal to 1/5.